Alright, so we're going to do something called binomial expansion. So before we do this, you have to remember from last year when you did something called permutations and combinations, and that is the formula for combinations here. So when you do combinations, it's a problem like this, like how many ways could you choose 3 of these different flavored Jolly Ranchers from the 5 flavors given to you? So what you're doing is 5 choose 3. So you're filling in this formula. You're doing this number here is your n, so you're doing 5 factorial. You're doing subtracting these 2, so 5 minus 3 is 2 factorial. And then you're doing the second number right there, this number, factorial. So remember that factorial means that you are multiplying, you're taking that number, like 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. So when you evaluate this, you can cross it off, like cross these off with those off, like whatever's bigger. So really I just have 20 over 2, which is 10. All right, now there is a way to do this on your calculator, so I'm going to show you that, but I'm just showing you like the main way, like the original way. All right, so remember the factorial symbol means to take that number and multiply it by the number before it, and then by the number before that, all the way down until you get to 1. 1 is the last number. You don't turn negative. So if you write 5 factorial, that's 5 times 4 times 3 times 2 times 1, which is, let's see, 60, 120. Okay. All right. So you need that. Now, this is also in your calculator. So the factorial button is in your calculator as well. So not the factorial, but we actually were interested in the combination one. So if I wanted to do 5 choose 3, it's often written long ways like this. What you do is you go ahead and put your 5 in, you press the math button, you go over to probability. You can go forward or you can wrap around backwards, it's faster, and there it is, NCR. And then there's the factorial as well. But anyway, you choose NCR, and then you put what you want, 3, and it pops out the answer for you. So that's what we're going to be doing. All right, so there is this little fancy triangle over here. So if you have 0 choose 0, that answer is 1. If you have 1 choose 0, like if you have one thing and you're going to choose nothing, well, there's one way to do that. You just literally choose nothing. If you have 2 things and you choose nothing, well, you choose nothing, so that's one way. Also on the other side, so these are all 1s down the side. On the other side, if you have one thing and you're going to take everything, there's one way to do that. You take them all. If you have 2 things and you take them all, well, there's one way to do that. You just take them all. So all the way down here is 1s. Now, we could go and figure out the rest of these inside here, but let me show you a little pattern. So this is Pascal's triangle. So basically, when you triangulate to another spot, you add the numbers above that. So like 1 plus 1, these kind of like triangulate to here. 1 plus 1 is 2. These 2 make that one. 1 plus 2 is 3. So if you remember these top 3 1s right here, and then you can start your next row. And this right here is 3. And so you can go and fill out the rest. Okay, so if you need something from like this pattern right here, you can make a triangle for yourself, but also realize that it starts with row 0, row 1, then row 2, and so forth. So on row 0, what you're going to be doing, what this does for us, is it tells us the coefficients of a binomial when you expand it. So I'm going to write this one, x plus y to the 0. Well, we all know that x plus y, and if you take it to the 0 power, you get 1. So look, there's a coefficient, 1. So anything in here to the 0 power would be 1. But try this one, x plus y to the 1st power. Well, first power, I mean, nothing changes. It's just x plus y. But look at the coefficients, 1 and 1. That's what these are representing. So x plus y squared this time on row 2. So it's x squared, x times y times 2, so plus 2xy, and then plus y squared. So look at the coefficients, 1, 2, 1. So if you were to do x plus y to the third and work it out, this is what you would get. You would get x to the third plus the next number would be 3. Now look here. What's happening, my x is starting off as the highest power. So now it's going to go down a level. But my y started off as nothing, and it goes up a level. So this is no y's. This is 1 y. The next part has a 3 again. My x has to dwindle down, so it has to be first power, but my y has to grow, so this has to be second power. And my last one is a 1, and my x goes down to nothing, but my y rises up to 3. So we could continue doing that here. If I do this one, I'll do it down here. If I had x plus y to the fourth, okay, so just to show you, that would be x to the fourth, and it's a 1 in front of it. The next part would have a 4. The x would go down to 3, but the y would start happening. And then the next one is also a 6. The x would go down to 2, but the y would grow. And the next one is 4. The x would go down to 1, but the y would grow to 3. And then the last one would be a 1 again, and the x would be gone completely, but the y would grow to 4. Okay, so that's kind of like the pattern. The first piece in the expansion grows, and the last piece, the first piece dies off, and the last piece grows. But these answers change because, these are very simple things over here. Okay, so that's the idea. So now we're going to expand some of these. So you just saw me expand, actually you could just saw me do all 3 of these right here. We'll write it out. So why don't I go ahead and I'll skip these 2, but let's write this one out. So when I have a 4 right here, how I start off, I'm going to pretend like we don't know about the triangle and everything there. We start off with 4, choose nothing. So that's how I'm going to get my coefficient. So remember, what I'm getting is I'm getting this piece right there. So 4, choose nothing. I take this first part, x, and I take it to the highest power. My y, I'm going to write it down, but I'm going to put a 0. These numbers always have to add to your power. The next part is 4, choose 1. X is only being 3 now, but y is going to grow. Then 4, choose 2. X is going to be a 2, but y is going to also grow to 2. And then 4, choose 3. And then x is going to go down to 1, and then y is going to grow to 3. And let's see, then 4, choose 4. X is going to be nothing, but y is going to be 4. And I'm asking what the middle term is, so 1, 2, here's my middle term right there. So 4, choose 2. I think I'll just, well, actually, so remember we can go up here. 4, math, choose 2. So that's 6. So I got 6x squared y squared. There's my middle term. Okay. So let's get to one that's a little bit harder or a little bit different because it has a 2 there. Okay. So here we go. So I got 5, choose 0. Then I have 2x to the 5th power, negative 1 to the nothing. All right. And you can do the 5, choose 0, or you can go to the 5th row here, right here, and you can write down these numbers. These are going to be the coefficients with the binomial expansion. So I could write 5, choose 1 here, or I could know that it's a 5 from that triangle. My 2x is going to get a 4th power. My negative 1 is going to get a 1st power. Remember, these add up to 5. All right, then 5, choose 2. 2x is now to the 3rd power. My negative 1 to the 2nd. 5, 3. 2x is to the 2nd, but negative 1 is to the 3rd. then 5, 4. 2x is to the first, but negative 1 is to the fourth. And then finally, 5, 5. 2x is to the nothing, but negative 1 is to the fifth. Okay, so now we just have to clean this up. 5 choose 0 is 1. I get 2x to the fifth, so I get 32x to the fifth, and then this is 1. 5 choose 1 is 5. 2 to the fourth, so that's 16x to the fourth, and there's a negative 1. 5 choose 2, I'm going to cheat over here. 5 choose 2 is 10. I get 8x to the third times 1. Then I get another 10. I get 4x squared, and this is a negative 1. Let's see, then I get another 5. I get a 2x and a 1. And for this last one, I get a 1, and a 1, and a negative 1. Okay, so here's my answer. This expanded out is 32x to the fifth plus, this is 80. Ooh, and actually that's a minus 80x to the fourth. This one will be plus 80x to the third. This guy will be a minus 40x squared plus 10x and minus 1. So there is the expansion, the full expansion of this guy. Now, you don't always have to fully expand that. Sometimes they're going to ask you for certain parts of it. Okay. All right, so let's look at this next one. So find the coefficient of x to the sixth. So let's set it up. I know that I'm going to be doing, so I have to find one part of this. I know I'm going to be doing 12, choose something, so we'll leave that blank for now. I know that x squared is going to be taken to some power. I know 3 is going to be taken to some power. All right, and so this is a binomial, and we're expanding it. We're finding one part of it. So x to the sixth. So the powers that go here are going to have to multiply by that 2. So think to yourself, what times 2 makes 6? Oh, 3 times 2, so that's going to be a 3. Remember these powers, they're going to add up to 12. So this has to be a 9. And then magically, you can put a 3 or a 9 here because of the triangle, remember how they're the same on either side? So if you put 12, choose 3, it's the same as 12, choose 9. Doesn't matter. So I think I will just put this, it literally doesn't matter, so I'll put 9. All right, so here's my answer. 12, 9 is 220. This is getting me x to the sixth, and 3 to the ninth, it's 19,683. So my final answer here, so times 220, it's pretty big. 4,330,260 x to the sixth. So that is the term that has x to the sixth. Okay. This guy is asking in a different way. What's the seventh term of this thing? So what's the seventh term? Let's see. So seventh term. So I would start off with 10 to something. Then I would have 2x to the third. To some power, and I would have negative 1 to some power. So if I want the seventh term, so the first term would have a 0 here. I'm sorry, a 0 there, but it would have a 10 up here. So the first term would have a 10, then it would go 9, 8, 7, 6, 5, 4, 3, 2, 1. So I want the seventh one. So 1, 2, 3, 4, 5, 6, 7. So there's my seventh power. So I'm going to be putting a 4 here. They have to add up to 10, so this will be 6. And remember, I can put 4 or 6 here. Doesn't matter. All right, so 10 choose 4 is 210. 16, so times 16, x to the 12th. Times 1, this turns out to be. So 210 times 16 is 3,360, x to the 12th. Okay? All right, So one last thing, you can stop now or whatever. I'm just going to show you how this would work with expansion of a complex number. You don't have to watch this part if you don't want, if you're tired and want to just go start your homework. But if you want to, remember we had De Moivre's theorem before. We had to find R, we had to find theta last chapter. Well, we can do this binomial expansion with what we just learned today if we want. So I could do 4, choose 0. I take my 2.